welcome to class. Thanks for being on time. I really appreciate it. I hope we've got at least double digits there today. Having around 14 or 15 would be great, but whoever's there, I thank you for being there and being there on time. Alright, I can't be there today, so I'm going to teach you anyway. And we're going to learn how to find unknown angles. So we actually did a lot of the setup for this last day, so it should kind of occur like review to start here, and we're going to do one last piece. So for example, in the first question here, I'm going to do a couple with you and then I'm going to leave you to do the rest. So in the first triangle here, we know two sides. This is 12. I don't know if it's 12 centimeters or what. Let's call it centimeters. Why not? It makes no difference. And let's say this is 16 centimeters here. Okay, the picture should look pretty much the same as yours. And it's a right triangle. And we're going to try to figure out both the angles. This angle I've labeled A here, this angle down here, this is the angle we're going to find first. We don't have to find that one first. We could find the angle up here, but just so we're all doing the same thing, let's find this angle first. And we'll do that for all the questions. We'll find angle A first. Okay, just like last day, remember we did something like this last day? What I want you to do is I want you to figure out which sides do we know here. Like we know this 12, we know this 16. What are the names of those sides? Okay, so we're going to look from the angle that we're trying to find here. We're trying to find angle A right here. This is the angle we're trying to find, right? So we're going to look from there, and we're going to ask ourselves, which sides do we know? Okay, well, what's this side? This long side here that we actually don't know? That's the hypotenuse, isn't it? The longest side's the hypotenuse. It's always across from the right angle, so this is the hypotenuse. But this is not one of the sides that we know, so let's not worry about that. The two sides that we know are the 12 and the 16. What's the 12? The 12 is opposite, right? If we came running out of that angle there, out of this corner right here, we'd hit the 12. That's the opposite one. Opposite. What's the 16 then? Well, if it's not opposite, it's not hypotenuse, it must be adjacent. Alright, you don't need to write all that down, the opposite, hypotenuse, adjacent here, but you do need to write up here the two sides that you have lengths for. So we have lengths for opposite, I'll just write op, and adjacent, I'll write adj. Great, step one is done. Step two, which ratio are we going to use? Okay, this is where you got to remember your SOHCAHTOA. SOHCAHTOA. And remember what it stands for? Might as well write it all down here. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tan equals opposite over adjacent. If you weren't here last day, make sure you're clear how I'm getting that from SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tan equals opposite over adjacent. Hopefully that makes sense. Okay, so in this particular case, we have an opposite and we have an adjacent. So which one of the ratios uses opposite and adjacent? Hey, it looks like it's this one right here, tan. So the ratio we're going to use is tan. And last day we stopped right there, but today we're going to take it one extra step. We're going to actually figure out what is this angle here? What is angle A? How do we do that? Well, what we know is that the tan ratio, remember sine, tan, and cos, they're just ratios. They're just comparison of the opposite length divided by the hypotenuse, the adjacent length divided by the length of the hypotenuse, the opposite divided by adjacent. In this case, we have the length of the opposite and we have the length of the adjacent. So we can figure out the tan ratio. The tan ratio is just going to be opposite divided by adjacent. So tan of angle A is equal to opposite, which is 12, you must write them in the right order, 12, over adjacent, which is 16. Okay, what's easier is if we write this as a decimal. So you pull out your calculator, which I have here. No, not there. Oh, sorry about this. Here, good, and we want to know what 12 divided by 16 is. 12 divided by 16 equals 0.75. Okay, back here. So tan A equals 0.75. Now, does that sound like that's what the angle would be? No, the angle is not 0.75 degrees. That's way too small. This is what the ratio is. If we know the ratio when we're trying to define the angle, we do inverse tan, or shift tan, or second tan. Remember, we did this last chapter, actually. This is tan to the negative 1 of 0.75. That's how we're going to get the answer. Okay, I couldn't find a great picture to show. So, for example, remember what you're going to do is you're going to do something like, you're not going to push tan. You're going to first of all, you're going to hit this shift button. Can you see that? This shift button here. For some of you, it'll say shift, or it'll say second, or it'll say inverse, and then you're going to hit tan. That's how you get inverse tan or shift tan. The other thing to remind you of is somewhere in your calculator, I don't think you can read it here, I think it's right there, it should say degrees, DEG, DGR. You do not want it to say rad or grad. If you have it on one of those two settings, you're going to get all these questions wrong today. So make sure it's on DEG or DGR, or it might just say D or something like that. Okay? Okay, so what we want to figure out is what is the inverse tan, or tan to the negative 1 of 0.75. So I'm going to figure that out by using my calculator. Now, as I said, on your calculator, you're going to have to hit shift or second or inverse like I just showed you. On this lovely calculator, it has inverse tan, tan negative 1. It has its own button, which is pretty nice. So I'm going to push that button, and then it comes up ATAN. I know that's confusing. It stands for arctan. It means the same thing as tan to the negative 1. And I put 0.75, I close the bracket if I want, and I hit equals, and I get an answer. I get 36.87. So in other words, what we've just found out is that this angle A right here, is 36.87 degrees. 36. Let's just do it to one decimal place. So it's 36.87. You could put 36.8. If you know how to round, that'd be 36.9 degrees. That would be our first answer. That's this angle right here is 36.9 degrees. Did you get how I did that? Yeah, I'll save it and I'll do one more example with you. Okay, the second missing angle. So we now know this angle is 36.9. We figured that out. We know this angle, don't we? How much is that angle? That's 90 degrees. And so we need to figure out this angle. How can we figure out that angle? We could do another tan. We could do tan of this equals 16 over 12, opposite over adjacent. But what can you do when you already know two of the angles? What do you know about all three angles in a triangle? Someone shout it out. Impress everyone. What do you know about the three angles in a triangle? They always add up to 180. If you don't know that, you might want to write that down somewhere. The three angles in any triangle, doesn't matter what the triangle looks like, always add up to 180 degrees. So that being the case, if we know this one's at 90 degrees and we know this is 36.9 degrees, how can we figure out this angle here? You could take 180 and subtract the two angles you know, the 90 degrees, and subtract the 36.9, and you will have the other angle. The other way you could do it, it's pretty much the same thing, is if you add the 90 and 36.9 together and then subtract that amount from the 180, you also get the answer. It's the same thing, really. Okay, so 180 take away 90 is 90, and then 90 take away 36.9 is 53.1 degrees. So there's my answer. This angle here is 36.9, this angle up here is 53.1. Alright, and you're just going to do the same thing for all these questions. I know I've given you quite a few, but I want you to really get this down. And I don't think they'll take you very long once you get into it. So for example, I'll do the next one with you and I'll do it much faster. We want to get angle A first. Which sides do we know? Okay, we don't know this side, so we're not interested in this side at all. We don't know this one. Okay, forget about this side. I don't know what all that mess means. Let me erase it. But one side we do know is we know this side, the 28. What's that side? That's the hypotenuse. That's the longest side. That's the side across from the right angle. What's this side here, the 11? That's opposite. If we came running out of there, we'd hit the 11, so that's our opposite. All right, which ratio uses hypotenuse and opposite? Let's go up and take a look. Opposite and hypotenuse and opposite, it's sine. Sine equals opposite over hypotenuse. So we're going to use the sine ratio. So we say sine of angle A equals, now remember, you have to do it in the right order. It's not hypotenuse over opposite, it's opposite over hypotenuse. So opposite is 11 and hypotenuse is 28. So 11 over 28. Let's turn it into a decimal. So I go to my calculator and I do 11 divided by 28, and you're going to get some crazy decimal. Oh, it's not that crazy at all. If you do get a crazy decimal, make sure you put it to at least 3 decimal places. Don't be rounding it off at 1. You want pretty accurate, so do at least 3 decimal places. So we get 0.39. 0.39. So that's the sine ratio. That's the ratio of opposite or hypotenuse. To get the angle, I do sine to the -1 of the 0.39, and that will give me the angle. So again, you're going to have to use your shift or your inverse or your second button, but my lovely calculator has a sine to the -1 button. So I just put sine to the -1 of, was it 0.39? I sure hope so. 0.39 equals 22.95, which basically rounds to 23. Let's call it 23. So 23 degrees. Okay, we now know this angle is 23 degrees. We also want to know this other angle, the second missing angle, this one here. How do we get that? Well, this is 23 degrees, this is 90 degrees. We know that the 3 angles always add up to 180, so we're going to do 180, take away the 90, take away the 23, and if you do that, you get 180 minus 90 is 90, 90 take away 23 is 67 degrees. And you're finished. And then you keep going. Some of them are going to be sine, some of them are going to be tan, some of them are going to be cos. Alright people, have fun and enjoy the right triangles.